Okay, so today we'll be talking about a thing we've been discussing a little bit previously, and that is the law of sines. So we've been using the trig ratios to solve right triangles, and in a right triangle you have two definite angles set up. You have a right angle and usually at least one other acute angle, and you're using that to find all the other pieces. Today we're going to look at situations where we're not in a right triangle. So we're going to use the law of sines as a tool to find the missing pieces in a triangle that is not right. If the triangle is not a right triangle, one of the options we have is the law of sines, and we'll talk about another one later. But where we're going to use the law of sines, and whenever we use the law of sines, we're using something that is based off of the relationships between angles and all of their opposite sides. So you're always looking for pairs of angles that can be matched up with a measure of the opposite side that it's across from. So that relationship is very critical. So as we look in this triangle here, you'll see that we have angle B, and the side across from it is side B. We have angle A. Of course, the side across from it is angle A is across from side A. And of course, you have angle C, which is across from side C. So don't necessarily memorize the letters of the triangle because they could be anything. However, in this situation, we're looking at angles that are matched up with these sides across from them. So in any triangle, and it doesn't matter whether it's a right triangle or any other kind of triangle, acute triangle, obtuse triangle, anything, we are dealing with a situation where the relationship of an angle's sine value over its opposite sides measure is equal to that of any other angle. So the sine of A over the side of A is equal to the sine of angle B over the length of side B, and the sine of angle C over the length of side C. So in order to use the law of sines, we're always looking for at least one set of an angle in its opposite side. We're not, if we don't have that, we really can't use what we call the law of sines. So we're always looking to establish that relationship. So let's take a look at this in an example. We have a triangle ABC, and we know the measurements. We know side B is 37.9. We know angle A is 33 degrees, and we know angle B is 105 degrees. Now, obviously, in this drawing that I've put on here, it is not to scale. That angle B is nowhere near 105 degrees in that drawing. However, we are going to use the mathematics behind all of this, and really the way the drawing looks is insignificant to what we're trying to do here. So we might just sketch out a triangle on our paper, ABC, and we kind of just look at these relationships between the angles and their opposite sides as we're going through this. So we can see that we have an angle B and its opposite side across from it. So we're going to use that relationship, and we're going to say sine of 105 degrees over 37.9. And we're going to use that, and we're going to use it to find angle or side A, since I have angle A. Angle A is 33 degrees, and we're going to look for its side. So we'll say that is equal to the sine of 33 degrees over the length of side A. Now, all this is a proportion, and we learned how to do these back in Algebra 1, maybe even before that, where we just cross multiply. So we'll take 37.9 and multiply it times the sine of 33. We'll take the value A and we'll multiply it times the sine of 105, and we get an equation. So we have A times the sine of 105 degrees is equal to 37.9 times the sine of 33. And this is just a simple equation. Remember, sine of 105 is just a value that we can get from our calculator or a table or anything else. And we're just going to take that, and we're going to isolate this angle or this value for side A by dividing sine of 105 over to the other side. In other words, I just divided it off this side and come over here and divide it to this side. So the value of A, the length of side A, is equal to 37.9 times the sine of 33, all divided by the sine of 105. And you can just pretty much punch that in your calculator, of course, making sure you're in degree mode. And you should get that the length of side A is 21.37. Now, if you're not getting that 21.37 from punching this in the calculator, you're probably punching something in wrong. So I would just break it down and type in the top part, get that value, and then divide that answer by the sine of 105 degrees. At any rate, you should get 21.37 as you do this. Now, we're going to move on to find side C. In order to find side C, though, I need to know what angle C is. Now, you'll see I just popped it up on the screen that angle C is 42 degrees. And if that catches you off guard, it's not like I did anything magic here. Remember, the Angle Sum Theorem tells us that the angles of a triangle equal out to be 180 degrees together. So we take 105 plus 33 is 138, leaving 42 degrees over to be sides, or angle C, excuse me. So we're going to use that angle, and the only missing piece now we have to find the rest of the triangle is side C. So we'll take angle C and side C and work with that relationship. And we'll go back and work with the one we had to start with, which was sine of 105 and 37.9. So we'll say that again, and it's going to be equal to the sine of 42 over C, because sine of 42 and the angle opposite, or the side opposite, excuse me, is what we're going to work with there. So again, it's pretty much a similar setup. We'll cross multiply. We get 37.9 times the sine of 42 is equal to the C, the value of C, times sine of 105. And we'll just take that. To get C by itself, we're going to divide by the sine of 105. And we'll find real quickly that our value for C is 26.25. And we're done. So that's pretty much the way you would use the law of sines to find the lengths of sides. Now, there is another situation that we can arise with and work with the angle sine, or the sine of an angle, excuse me. And that's when we have to find the angle itself. And you'll remember we've talked about in class that when you're trying to find the measure of an angle, we use arc sine or arc cosine or arc tangent, whatever function we're using. Here we're using the sine function, so we're going to use arc sine if we're trying to find the measure of an angle. You will see in this case I have two sides and I have an angle. And I'm going to try and solve this triangle, finding all the missing pieces, which would be angle B, angle C, and side B. So in order to work with this, I'm going to have to find one of these angles. I have a relationship with angle A and the side across from it, so I'm going to use that. That'll be the first thing that I set up. I'll say sine of 51 over 40 because I know those are two pieces that I have the measures of. Now I am going to try and find angle C because I have side C over here is 50, and I'm going to work with the angle over here across from that. So I'll say the sine of C divided by 50 is equal to this ratio of sine of 51 over 40. And again, we cross multiply. 50 times sine of 51 is equal to 40 times the sine of C. We're going to try and get the sine of C by itself. Actually, we're trying to get the capital C, the angle C, by itself. So we'll first off divide by 40. And you'll remember, if we're trying to find the measure of an angle, we're going to get rid of this sine function by doing the inverse function, or the arc sine of that value. So you can try to punch this all in the calculator at once. If you're not really good with parentheses and things like that in the calculator, you might have some problems. So maybe you want to try and find this value first and divide it by 40 and then do the arc sine of whatever your answer is. But this is what you're going to do. You're going to use the arc sine to find the measure of angle C. And when we punch that in, you should quickly find that the measure of angle C, I have it carried out to two decimal places here, 76.27 degrees. So I'm going to put that in there. You can call that 76.3, and that's quite all right. I wouldn't round it to the nearest whole degree unless you were told to do so. But I went to 2 decimal places here just for the sake of carrying things out a little bit more precisely. But once we have that, we can work with this relationship now, and we know that the angles are going to add up to be 180, so we can quickly find that angle B is also going to be 52.73 or 52.7, depending on how you rounded there. And we'll use that relationship to find side B over here that we were missing. So we'll say we'll work with the one we started with, was angle A over 40, sine of 51 over 40, and we'll say that is equal to the sine of B, or the sine of 52.73, over side B. And again, we're just going to cross multiply, and in doing so, we get that B times the sine of 51 is equal to 40 times the sine of 52.73. And from there, it's just an equation to solve. We'll get B by itself by dividing by sine of 51 on both sides. So we have B is equal to 40 times the sine of 52.73 divided by 51 degrees. And that will tell you real quickly, once you punch that all in, that the length of side B is approximately 40.96. If you were going to round to the nearest tenth, you'd call that 41.0. So there you go. And, you know, this is a situation where we did not have the measure of an angle to start off with. So we had to start off by using arc sine, and then we established relationships to go from there and find the missing side. So law of sines is always very useful in doing this whenever you're working with a non-right triangle. Of course, it also applies to a right triangle as well. You can just use the sine of 90 over the hypotenuse is equal to the sine of another angle over its leg, and you can continue to work with it the same way. At this point, we're going to try and take a couple of practice problems that I'm going to go through with you. I want you to, excuse me, let me see if I can get them pulled up here. Here's the first one. We're going to kind of work through this together. You'll notice I have it here on the screen, and I want you to take a minute and think about what we would do. I'm going to go ahead and label the pieces, and we'll go from there. Okay, so let's take a look at this example here. In this example, I've got angle A as 40 degrees. I've got angle B as 59 degrees, and side C is 14. Now, as you look at this, you're going to notice that there's not really a relationship between an angle and its opposite side. The only side I have here is 14, and that would mean that I need to know this angle here, angle C. So we're going to have to do a little work here and a little thinking. If we use the idea that all triangles have angles that add up to be 180 degrees, we'll see that 40 and 59 add together to be 99, and that leaves a measure of 81 degrees here for this angle. And maybe I might type that in. So let's see if I can type that in here. Let's see, 81, I pushed 82. That's 81 degrees. And we'll move that up here a little bit and get an angle C. So you can see that we're just using the Angle Sum Theorem there to find that measure. And that's what we're dealing with. So in doing that, I've set up a relationship now that I can use, and that is that the sine of 81 over 14 is going to be equal to the sine of any other angle over its side. So I'll start with this angle A, since it's usually the smallest angle we want to start with. We usually like to work with the smallest angles first and then go from there. So we'll start with sine of 40, and we will divide that by the length of side A. And then we're gonna cross multiply, just like we've been doing so far. So we'll take this and multiply over, and that's what we're gonna deal with. We'll have, let me change my color again. We'll have A times the sine of 81, and that's going to be equal to 14 times the sine of 40. And again, my handwriting is pretty sloppy here on the screen, but I'm trying to talk and write with a stylus at the same time, but hopefully you see what I'm doing here. We're going to try and isolate the length of side A again. That's what we're trying to solve for. So we're going to go back here, and we're going to divide by the sine of 81 on both sides, and that's going to leave this value of A by itself. So when we do that, we're going to find the length of side A is going to be 9.11 or 9.1, and now we have two sides. Now some of you may be thinking at this point we can use Pythagorean Theorem, and if you take a second you'll realize there's a reason why we cannot do that. Hopefully you're seeing that we can't do that because this is a triangle that is not right. The Pythagorean Theorem only works for right triangles and the hypotenuse and the leg. So we can't do that here. So we're just going to go with what we have. And then we're going to go and jump into this relationship between angle B, which we know is 59 degrees, and its opposite leg or opposite side, which is side B. So we'll try and set up again the relationship. We're going to again use this 81 and the 14 that we know is correct, and we might have, just in case we made a mistake with that 9.11. I'm feeling pretty confident about it though. But we'll say that the sine of 81 over 14 is equal to the sine of 59. Ooh, that was messy. I'm going to have to erase that because I'm just a little bit of a perfectionist there. Sorry. So the sine of 59 over B. And again, we're going to cross multiply like we've been doing. B times sine of 81 and 14 times sine of 59. And that will give us our equation. 14 sine of 59 is equal to B times the sine of 81. And to solve, we just divide. We're trying to get B by itself again, so we're going to divide by the sine of 81 on both sides. And that gives us our solution. It tells us that B is equal to approximately 12.15, which is a cool number for me. That's my birthday, 12.15. So we'll kind of say this is 12.15, and we're done. We have the triangle solved, and we have found all the missing angles, and we found all the missing sides, and we can move along to the next problem. So that would be our example there. Now let's try another one. You'll notice this scenario is a little different in that we're missing a little bit of different information. So at this point, you can see I've kind of got some pieces put in there. We're looking at a situation where we know that angle A is 82 degrees. We know that side A across from it is 14, and that's a relationship that we're going to want to use to our advantage here. But you'll notice that in this case I have the length of side B, but I don't know what this length over here is. So we're going to have to find some way to find angle B first, because otherwise we won't be able to find angle C, because in this relationship I don't have anything going on between those two at this point in time. So we're going to have to find angle B first. So we'll set up our equation, or our proportion. We'll say the sine of 82 over 14, which is the relationship we had set up first. And we're going to say that's equal to the sine of B over 9. Now, this is again, another situation where we're finding an angle, and you should already be thinking of some things that we've talked about. When you're finding an angle, you're going to have to end up doing an arc sine in your last step. So we first start off and we cross multiply, so we'll have 9 times the sine of 82. Sorry for being sloppy. And that's going to be equal to 14 times the sine of B. Now, the first thing I'm going to want to do, I'm trying to get this sine of B by itself, and I'm going to divide, to isolate this, I'll divide by 14 on both sides. So now I have that the sine of B is equal to 9 times the sine of 82, all divided by 14. Now, I know I just wrote that all in red. Hopefully that doesn't confuse you. I also switched the signs, but it's the same thing. So I have sine of B is equal to 9 times the sine of 82, all divided by 14. And my only answer to this is to take the arc sine of both sides. So I want to take, and let me switch to a different color here. I'm going to take the arc sine of this, and I'm going to take the arc sine of this thing over here. Now, in doing so, that leaves me with B on this side. And when you work all this out, you take, and I should have probably written it over here on this side, but you'll have arc sine of all of that, 9 times sine of 82 divided by 14, and you're going to work out this value here, and then you'll take the arc sine of your answer, and you will get that the measure of angle B is approximately 39.5. Now, that is the first step in solving this triangle. So we will take that information and we will punch it in up here, angle B. Give me just a second here, and we'll say that that's equal to, we said 39.5 degrees. You might hear my son talking in the background. He's in the next room talking to his friends. I think they're playing Fortnite together. At any rate, so we see the relationship here we've established between these two pieces is what we're gonna use as our basis there in the law of sine. So what I'm going to do now is kind of clear out some space here, but you can see how I got that. I do have one, or actually two more pieces to find. Hopefully you're also seeing that we can use the Angle Sum Theorem, and we take 82 and 39.5, add them together and subtract from 180, and you should find that our equation here, or our angle is 58.5 degrees for angle C, and we'll take that information and continue to work with it as we go through the law of sines now. So we're going to take this and we're going to now use all that to find what angle C comes out, or side C, is going to come out to be. So let me clear out some space here, and we'll then find the length of. Okay, so I've cleared that out, and again, we're going to work with this relationship between angle C and side C. We're going to start off again though with the sine of 82 and its opposite side, which we know is 14. And we're going to say that's equal to the sine of 5 over c. And we're going to cross multiply just like we normally would, and that would give us our equations. 14 times the sine of 58.5. I'm just going to have to go with that. It's hard for me to write here. And c times the sine of 82. And as we go through here, we're going to divide both sides. Again, we're trying to get c by itself, so we're going to divide by the sine of 82. And that leaves me with c. And when we punch all this into the calculator, you should get that side c has a length of 12. We'll call it, it says 12.05 basically. You may just want to call it 12.1 when you get in here and write your answer out. So we'll call that 12.1. And we are done. So we found that our angle here was 39.5. That led us to say this angle was 58.5. And then we use that to find the length of side C. At any rate, hopefully you're seeing now, I know some of you are a little apprehensive about the law of sines through talking to you, and hopefully you're seeing now that this is really just a matter of setting up the proportions appropriately and then cross multiplying and solving the equation. Hope to see you in class, and we'll discuss this a little bit further. Until then, have a good day.